How's it, guys? Today I'm going to talk about the standard sort algorithm and basically how to use it in C++. And the idea here, or the aim here, is that this is targeted towards someone who's started using vectors now, and they usually use the bubble sort, and they're pushing back structures and stuff like that to the vector, and they want to sort it, and can't figure out why the compiler isn't happy with them saying sort from the beginning to the end. So this is aimed at someone who doesn't have full experience with C++, so I'm not going to use constructors and stuff with the structs. I'm going to try to keep everything simple. I already made a video like this recently, and a user by the name of Peter Olen, I hope that's how you pronounce it, corrected me on an error that I made, and I'm going to fix it up in this video, and I'll specify what the error was, but thank you very much for letting me know about that. So basically, let's get started on this. Let's say you have a struct called client, and this structure has, let's say, a name, surname, let's give it an account number, and let's also just give it something else. I'm going to call this secret. So you actually don't know what secret is. Okay. Okay, so let's create a client. So client cl1, and we're going to say cl1.name equals John, and cl1.surname equals Tanner, and let's go cl1.num equals 10, and cl1.secret equals 7.88. Okay, so this is our first client. Let's create a vector of these clients as well. So we're going to go vector client, and we're going to create a vector called clients. And over here we're going to go clients dot push back cl1. Okay, so of course to make this more efficient and everything, we would actually just make a constructor in the struct, and we'd push back constructed. Well, we'd call the constructor as we push them back into the vector. But for now, let's just leave it like this. Okay, so I'm going to make a second client, and we'll call this client. Let's call it Jane Doe, and she can have a number of 17, a secret of 3.14. Okay, next one. Okay, now this one, what I'm going to do is I'm going to try to keep the name as close to John as possible. So let's go like John, for example, and this could be something else. Let's say Bauer. Okay, and a number of 5, or let's make it minus 5, and a secret of 97.6. Okay, and let's make another one. Let's just go here. CL, what are we on? 4. Okay, so now we're going to make, let's do for Jane, we'll call her something else. We'll go Anne, and her surname was Doe. So let's make another one called Doe. So it's exactly the same. And number 0, secret, minus 4,000, and push that one back, and then let's make a final one. And what can we do here? Let's do something where we make it exactly the same with John Tanner, but we'll just make this number, let's say 11, and this one 9.99. Okay, cool. So we've changed all of these clients. We've got a different client for each one, and we've pushed them all back to a vector. So at the moment, this should compile. We shouldn't actually have a problem at all. So let's take a look at that. Let's try. So I'm going to go g++ main.cpp. All right, cool. That's perfect. So it's there and it runs. No problem at all. Okay, cool. But now we want to call the sort function. So we say sort, and we're going to do it from the start. So that's why we go client.begin. And we want to do it to the end. So we go clients.end. Now these are iterators that you're sending in. So you're saying start at the start, end at the end. And it iterates through from this iterator to this one. Okay, that means that you don't have to sort a whole vector. You could send in the beginning to the middle, or maybe the middle to the end. You can send in any iterators, provided this one is before this one. Okay, so now we call sort. So now we expect it to sort this vector, right? So let's try compile that. Let's see. Here we go. So I'm going to compile. Okay, it doesn't know. Okay, there's a huge crash, and I'll tell you why. So the standard sort algorithm doesn't know how to compare one client to another. Okay, what makes, for example, client 1 greater than client 2? How do you know that John Tanner with 10 and 7.88 is greater than Jane Doe with 17 and 3.14? You don't, right? I mean, how do you sort that? Do you sort it by the name, the surname, the number, the secret? Which one do you use? Okay. And that's what you've got to actually tell the compiler. You've got to tell the compiler you need to sort by a specific type. So let's make one called, let's sort by number, so comp num. And what you send in is you send in a client, 2 clients, and we're going to compare the two. But we're going to compare the number, this int number. Okay. So how would we compare that? We would return that maybe LHS.num is greater than RHS.num. Okay. What does that mean? It just means that this client's number is greater than that one. Okay. And I'm just going to make a quick print algorithm. So we're going to send in a vector of clients or client, and we'll call this clients. And okay, just for efficiency and stuff, we'd send it by reference and we'd make it constant. Okay, so we're going to send in this vector of clients, and all we're going to do is we're going to go for int or unsigned. Okay, I'm not going to use C++ 11 standards yet, so that's why I'm going to use unsigned int instead of auto. So we will do for unsigned int I equals 0, I does not equal clients.size, I plus plus. Okay, and what we're going to do is we're going to see out the clients.@I.name, and then we'll do the surname. Let's do, whoops, now my mouse is not working. Okay, we're going to do the surname as well. Then we'll do the clients.@I. Okay, .num, and then finally clients.@I. What's the last one? Secret. Okay, and okay, so that'll output everything. Let's just put a couple on end line there. Okay, so if I print, let's just comment out this line for now, and let's just go print clients for now. Okay, so this is what the vector will have in it at the moment. If we compile. Didn't like print. Why not? Oh, whoops. Okay, the reason is that I didn't declare this prototype above. Let's just put a prototype up here. Okay. Here we go. Let's try again. Okay, cool. So do you see here? It prints out John Tanner, Jane Doe, John Bauer, Ando, and then John Tanner again, but this is a different John Tanner. Okay, and it looks like I didn't put a space between the number and the secret, so let's just put that. Okay, cool. So we're printing out things, but at the moment we're unable to sort. What happens if I now say that I want to sort by the number, right? I want to sort by num. So what I'm going to use is the comp num function to compare these two. So I just put in comp num. Use comp num. Okay, we're going to print before and after we do this sort of using comp num, and let's take a look at what it looks like. So let's go here and print it out. So originally it was John Tanner, Jane Doe, John Bauer, blah blah blah, and now you can see that it starts with Jane Doe, it then goes John Tanner, both of them, and Doe, and then John Bauer. And you see how it's first 17, then 11, then 10, then 0, then -5. So it's successfully sorting by the comp number thing. Now there's a very, very, very important rule that comes down to these comparisons. And that's the fact that it must always return that 1 is greater or less than, like as in 1 always precedes another element. In my case, in the previous video, I also returned true if they were equal, which is not okay. Because then if you say, is A greater than B, it would say true, and then you say is B greater than A, and it would say true, and you would have this huge crash. You would have I think it's not a segfault, but it's something similar to that, because basically it would just be switching around. It would say is client 1 greater than client 2, and the thing would say true, and then it would say is client 2 greater than client 1, and it would say true, so it just wouldn't know what to do. So this is where you need to make sure that you'll always return that 1 is greater than the other, and it will never return true for if it's less than or equal to the other one. So let's make another one. Let's say we want to compare by name. So we'll say bool comp name, Okay, and we're going to go client LHS and client RHS. Okay. In this case, guys, if you want to do efficient programming, you would do a const client ampersand. So you'd be sending things by reference and everything, so you're not recreating these objects every single time. Okay, so first thing, what happens if the one is empty and the other one's not? So we say if LHS is empty and okay, and not RHS dot empty. So we're just saying that the one is empty, the left one's empty, and the right one's not. Then is left one greater than right one? No. Okay. Now let's see if not LHS dot empty, but RHS is empty. Okay, so that means that the one string is not empty and the other one is. Then return true. Okay, so in this case we just reverse it. So we say, is the left hand one empty and the right hand one not empty? If that's true, then the right one is greater than the left one, so we return false. In this case, if the left one isn't empty and the right one is, then the left one is greater, so we return true. That's the first one. Those are the first checks. Now what if they're equal? So if LHS is equal to RHS, and this is all of these must be dot name, okay, because we're sorting by name. I apologize for that. So let's just go dot name. Okay, so if your LHS name equals RHS name, then we're going to return false, right? Because then it means that the left-hand side is not greater than the right-hand side. Okay, so that's really important. Okay, and what the compiler does now is it says, is LHS name dot name greater than RHS dot name? And it's going to get false, right? Whoops. Okay, and then we do the same thing, except now we do RHS and LHS, right? So now is RHS greater than LHS, and it's also going to return false. And by doing these two checks, it now knows that they're equal. Okay, but okay, so we've already sorted out that the LHS side is, for example, if there's empty ones or if they're equal. We've sorted out all of those problems. Now we need to go through each character, and we need to see if one is greater than the other. So let's go unsigned int position, and we're going to set that to 0. So we're going to start with the first character, and we're just going to say while LHS.name while position does not equal LHS.name.size. So while we're not at the end of the left-hand side string, and while position does not equal RHS.name.size, okay, then we can keep going through this while loop, and obviously we're going to increase position each time. So the first thing is we're going to do is we're going to say char LHS character equals LHS.at.name.at pos, so our current position, and we'll do the right hand side, we'll do the exact same thing for that. So it's going to be RHS, and here it's going to be RHS. Okay, but let's actually take this and we'll go lower case. Okay, actually I think it's two lower, and here we're going to do two lower as well. So basically what we're doing is we're getting the lowercase, because sometimes you might have capitals and stuff. We don't really care about that. Okay, so we've got these two characters, and now what we say is if the left-hand side character is equal to the right-hand side character, what do? Well, at the moment, it means that the surname is pretty much exactly the same. So we'll just continue. Well, we'll increase our position, and we'll continue the while to the next step. Okay? What if that's not true? So if they're not equal, well then, what we're going to return is, or let me just do it like this. Just for this, I don't really want to use continue here. So if the left-hand side does not equal the right-hand side, that means that we have maybe, for example, that the left-hand side character is an A and this one's a Z. Okay, we return that the left-hand side character is less than the right-hand side character. Okay, so that will mean that A, because in ASCII values, A is less than Z. Okay, cool. Otherwise, if that's not the case, then we increase our position and we move on to the next one. there is a chance that we'll get through the whole surname, and they, for example, if you have Tan and Tanner, you'll go T is the same, A is the same, N is the same, but now we'll get to the point that the left hand side is now at its size and the right hand side isn't, so we're going to get here. So what happens if we know that is the position equal to the LHS.name.size? Okay, if that's true, if we are at the end of the left hand side, is tan greater than Tanner? I'm going to go with yes, right? So I'm going to say that, for example, we want Tan to be ahead of Tanner. Okay, so we're going to return true. Okay, now if that's not the case, that means that we got to the point that position was actually equal to the right hand side name. So then we'll return false. Okay, now we've taken care of all of the different ways that we can sort the name. So now let's do a sort of using the comp name function. So here we go, comp name, and let's take a look and see how that looks. So g++ main, why do we have an error here? Too lower. Whoops. Okay, so basically I just made a mistake here. It should be too lower, like that. Okay, let's check that out. Okay. And now we can see that we've sorted by the name. So it goes Anne, Jane, John, John Bauer. And these ones, if they were different in a different position in the vector, they would just be swapped around. So it doesn't sort those ones because they were exactly the same. Okay, so you agree that that's now working by sorting the name. What if we wanted to sort surname? Okay, of course, with the dry principle and stuff, this would be a very wrong way of doing it, but I'm just going to do this for now, so we can just see how to do that. So, for example, if we want to sort by surname, instead of these all being name, they would all just be surname, right? So that would mean that here we go, surname. Okay, cool. But what if I wanted to sort it the opposite way? So I wanted to sort it that from Z at the top and A at the bottom. So we just change this to greater than, right? Because now it means that when my ASCII value is greater than the other one, then it would precede the other one. So let's take a look at that. Let's check what that looks like. If I now create another sort and I sort by comp surname. Okay, let's take a look. Alright, we compile, run it. Okay, and check how it's gone TTDDB. So do you see how here I sorted by name and I made it A is the top and Z would be the bottom. Here I've made that Z is the top and A would be at the bottom. And you see how it's sorting there. And finally, for let's say, for example, for the secret, I'd ask that maybe you guys could do that, but just for interest's sake, if you can't figure out how, let's take this prototype here, and now what we're going to do is sort by secret. So what we're going to return is the left hand side secret maybe less than the right hand side secret. Okay, cool. And let's do a comparison there and sort it by that. So there we go, sort by comp secret, and I'll just need to change the name of this function. Comp secret, done. Okay, let's take a look now. If we do the same thing, compile, run it, and now it's sorting by smallest to largest. Okay, so this is just basically an introduction in how you can use the standard sort algorithm. Yeah, you get a core dump if you don't create these functions correctly, because what happens is if it can't see when two are equivalent, then it will keep just comparing them to each other, and it will just keep crashing, because it's going to say, yes, the left-hand side is greater than the right-hand side. Then on the other hand, the right-hand side is greater than the left-hand side. So your program is just not going to know what to do. So yeah, so this is just an introduction to the sort algorithm. I do want to say thank you to the YouTube YouTubers out there that did correct me on that, because we obviously don't want garbage out on the internet. So thank you very much for that. And yeah, I hope this does explain why we need to sort, or how we can sort a vector of structs or classes or whatever you want. As long as you've specified the comparison function, you can sort anything. Okay, so just make sure that you are telling the standard algorithm how to sort your struct. So these structs could be anything, and as long as you've programmed the comparison function, you should be fine if it's programmed correctly. So thanks for watching. I hope this does help. Cheers.